Welcome to the Voices of the Internet of Things. This is Chuck Martin, and we're live at the Siemens Connects conference in Princeton, New Jersey. With today is Raj Batra, President of Digital Factory of Siemens. Welcome here, Raj.
Thank you, Chuck. Good to be here.
So tell me, Digital Factory, that almost sounds like an oxymoron.
Yeah. Well, you know, when we first named it Digital Factory, and it came from industry automation, this was several years ago, and the digital transformation was really just taking hold. But for Siemens, you know, we've been at digitalization for a good solid decade. You know, it started more or less with the acquisition of the UGS software portfolio, and people couldn't imagine back then, you know, why in God's name would the world's leader in industry automation buy a software company? And you know, the value creation of software in the design and development of products, manufacturing processes, production, simulation just become, you know, is such a critical factor going forward. So the goal was to really marry both the environments from the virtual environments of design and simulation of products all the way to the real environment of manufacturing and equipment and technology on the floor.
So was that just a natural evolution?
Yeah, it was our view that you know, again, a big part of production costs are predetermined in the product design phase. So if you don't have control of the design, you really don't have control of your manufacturing costs. And, you know, those slogans have been around for a long time in manufacturing, but inherently technology was never there to be able to do it. So software in product data management, product design, computer-aided engineering, you know, being able to have all of this on a common digital thread really lets us do a lot with the manufacturing process, with the design of products and then the corresponding manufacturing process for those products.
So what was first? Was it the back-end manufacturing for cost savings, or was it the design?
Well, you know, they both were handled in different environments. And if you go historically, even today, to any major enterprise, you know, you have a very, very strong IT organization and a CIO organization, you know, very true in our Fortune 500. And then you have a good manufacturing base and a good OT organization. And I can't say everything was as connected as we would like it. You know, so there are a lot of cultural barriers there, and those are being broken down today as we merge both those environments.
So has the entire market sort of awakened now to this?
Well, it's certainly an awareness topic, and it's scalable. So companies have to take steps. So I think you see a lot of companies doing a lot of advanced simulation and using software design to ideate products, to design products. But it's not necessarily that they use a common digital backbone between the design of a product and the manufacturing process. Because again, we want to, you know, the ultimate goal is to build the most holistic digital twins possible. Digital twin of the product, the production process, and then the performance. And so being able to do all three of these in one common environment.
So is this something that a Siemens has to sell, or is it something that a company wants to buy?
You know, a company should need to do this. And yeah, of course, in that consequence comes what we're providing is technologies and tools. You know, and I think when you look at this holistically from end to end, companies in many cases need to be educated on what's possible and what's benchmark, right? So if you want to get your defect per million lower and your quality rates higher, and you want to be able to manufacture with much greater efficiency, it's absolutely an imperative to have to do this. So you know, companies are understanding that these environments have to be linked. And in many cases, they buy all the products needed, but they don't take the cultural step to interlink them. So there's a cultural transformation in the operations also.
Isn't that the hard part?
It is. And I think especially for brownfield environments, especially where we have people that are working in manufacturing environments that don't necessarily have the desire to go on the cutting edge. Right, and so maybe a part of the aging workforce topic sometimes isn't all bad, because you know, you bring a lot of tech savvy new people into the work environment, even though we have a lot of people eligible for retirement. And I know there's the adage about the retirement time bomb, and sure, it's bad because you lose a lot of tribal knowledge in manufacturing environments, but maybe the flip side of that is the people that are coming in absolutely expect to do this. because that's how they've grown up.
So factory automation is not new as a concept. What changed with IoT?
Well, factory automation is not new, but again, simulation and digitalization in those environments is absolutely new. And new meaning that, again, you can use virtualization in any part of the process. So it's not just having to interlink the design of products to the manufacturing of products. It could be also that you go purely to the automation systems on the floor and you're able to simulate those before you do physical coding and do physical work on the floor. And we have so many cases where people have used virtual commissioning and virtual in designing the automation systems, and you see a 30% reduction in engineering time, more accuracy when they physically deploy the system on the floor. So it can happen in scalable blocks.
So is simulation the big thing then?
Well, I think it's one of the big decisive advantages for manufacturing.
So how does a project typically start? Does it start small? Does a company say, we have this big problem we want to solve?
Yeah, so when companies want to simulate, I think, so they decide what they want to simulate, and there are tools available to simulate the automation system. So before you go physically buy automation, you code it out in the field, and you put you see a lot of people historically that have been sitting in a control cabinet and they're coding, right? So that would all happen in the back office environment, and then they decide what they want to simulate. So in many cases they'll do a simulation of the line, the layouts of the factory. They'll simulate all the movements of equipment, and then there's a way to simulate loads in automation systems, and so you put it all together, and then you can address that part of the process, right. The digital twin of the production.
Right. What are the differences, if any, by market?
Well, I think you're going to see more progressive environments than others, right? And so there's certain environments that are very progressive. And that just don't have a choice. You probably see a lot of this in the discrete manufacturing industry, more in the auto industry, semiconductor electronics, where they're using all these advanced tools, but again, not necessarily in all cases linking them together. So, and using the integrated whole.
So can you talk a bit about automotive? We saw this morning the presentation, where the car is going to be built kind of by itself.
Yeah.
Where does all of that fit with what Siemens does?
I think we're right in the middle of it, and then I think we're a pioneer in the space. In the automotive industry, you have mass customization in play, and you have millions of buildable combinations of cars and products, and one color after the other, and designs are changing very, very quickly. You just can't wait to have a line dedicated to build one type of car, not have the flexibility in the line. So the way to do it is to really digitalize the operation.
And what about autonomous vehicles? Does that fit? Is that the same thing pretty much?
Autonomous vehicles, well, it's because it's still the production of a vehicle, right? And so in whatever form that takes, even if it's electrification, there's still a body. There's differences in the powertrain. But we're very active again in the design of the motor technology, of the assembly process, of putting the vehicle together, and all that we do. So all those same domain expertise and discipline areas still apply.
So how far ahead do you have to think?
Well, I think that when we talk about Industry 4.0, I mean the ideal state is environments where machines optimize other machines, and the product tells the machine what to do. Right, and so it's not necessarily humans doing all the optimization, but machines will optimize the machines. And this is where AI comes in, and the edge comes in, and you're able to use all these advanced technologies to do things that are not necessarily detectable to a human.
Are we close to that?
Yeah, it's there. I mean, it's there are products available today.
So how does a company stay ahead of a competitor?
Well, I think the first part of it is thinking about how to make manufacturing a competitive weapon. And I think in the country here, there's certainly been an adage that if you outsource a bit and you get it to low-cost environments, as long as there's some productivity, then there are incremental gains in having that kind of productivity. But I think it probably wasn't the thinking that's occurring now. Where companies are saying, look, if I can digitalize this and use digitalization as a competitive weapon, I can manufacture and potentially become a net exporter and do things with such high quality, with high-tech, high-value goods, that it's going to give me a world advantage, versus just throwing a lot of labor at a problem, right? And I think this is where companies will go to really get the next increment of productivity.
So is this, it used to be that basically it was cost savings in manufacturing. I mean, just quickly to the bottom line. Because of your design capabilities now, is that starting to look for companies as new revenue? So if in manufacturing, you'd be saving money by automation, obviously.
Yes.
But that doesn't involve new revenue necessarily. It just means cost savings.
Yeah.
Because you can now design on the other end, does that start to lead companies to think about new revenue streams?
Well, I think what it's going to let them do is think about how fast they can innovate and ideate different products, right? Because you can run, any different type of combination one after the other. And it's not just true in the automotive industry, it's true in apparel. It's true in anything that has a mass customization play, where mass customization is happening a lot faster than 18 or 24 months, where brands and designs and trends and how people want to order, this is all changing. And so the fact that you can do this in a environment where you don't physically have to always have a factory and test it, proof it out, perfect it, becomes really powerful for a company to do much more experimentation.
These projects typically pretty long in time?
Well, I think you have ecosystems today in these companies where a lot of this simulation work is being done, and certainly in the progressive industries, where a lot of this is being done, but again, may not be, fully tied together because people don't know that they have the tools to be able to do it, right? And so in some industries, it may be a long process, where you have aging assets on the floor and technology is not modern. But in other industries, they're using tools and advanced simulation tools, but now there's a next increment of productivity, and that's to really link it together.
So what stops companies from doing this?
Would say there's a big part of this that's cultural, and maybe a bit of resistance to adapt new things, and there is some fundamental change in how IT and OT come together.
So what keeps you awake at night?
Well, the fact is it going to happen fast enough, right? And how fast can we get this moving? Because technology is there, and the solution sets are there, and the backbone's there. And so when you've seen it from my side, you've seen benchmark facilities that do it great, and we have some of these in Siemens ourselves. We're one of the biggest manufacturers in the world, and we have 250 plus factories all over the world doing all different types of combinations of products, and so we have some really world-class factories that have done this and are benefiting big time from it.
And do companies look at, in terms of your customers, do they look at another company and say, we want to do that?
Well, I think benchmarking is important, right? And so we always encourage companies that, look, if you can do like benchmarking in certain industries, that can pay off in some big dividends.
So what does the labor force look like in the future in that context?
Well, I think the jobs are going to change, right? So it's not going to be a menial job anymore. I mean, you got to touch a robot, a computer, a laser, a welder, and there's going to be AI. There's going to be things that probably help them do their job better. But the human's going to be an ever important part of the process.
So it's going to be basically tech-based?
Yeah, I think you're going to find even jobs on the floor are I think that's part of the stigma of manufacturing, that people see it still as a dirty, grungy job, where there's grease under your fingernails, and that's just not the case anymore. These are some of the cleanest, most advanced environments in the world, right? And for all that we talked about, you're going to see much more robotics, you're going to see much more artificial intelligence, and but the humans are going to be there to help make decisions and help innovate and help do more of the pioneering work as to what they want the process to look like.
Right. Lastly, where do robotics fit in all of this?
Well, I think you're going to have a surge of robotics. I mean, they're just things that robots do that humans will never do. And when we talk about safe human-robot cooperation and collaboration, you're going to see humans working side by side with robots doing things.
Thank you, Raj, and thank you all for listening to the Voices of the Internet of Things.
Thank you.